Hello and welcome back to my channel. In this video, we are going to start making our way through the semifinal cases of this year's Microsoft Excel World Championship. The first of those two cases is Bushland Adventures by Nick Boberg. Let me read the introduction here to you. Welcome to Bushland, the best place for a hiking adventure in the Excel universe. The terrain and topography of Bushland is mapped out on two sheets, terrain map and topographic map. You are able to move across each map through directly adjacent cells but not diagonally. Movement from one cell to the next represents 500 meters. Each type of terrain affects how fast you move. Your base speed for each terrain is listed in the table to the right. So here we have the information for the base speed. We have further instructions about the items we're going to pack, which are listed here. And what we're going to do in this case is calculate how long a hike takes. Plan well and enjoy your hiking adventures in Bushland. So if I just go real quick, so here is the map of the terrain that we are looking at. Nice colorful map here. Here is a map of the topography of Bushland. So we have heights measured by how dark the color is. And we are going to use all of that information to build our model. So come along with me and let's see how long it will take to get a complete solve. Here we go. Alright, so level 1. How heavy will your pack be for the following heights? Provide your answer in grams. So we have a hike length of 2.3 hours. Let me go back up here and let's go ahead and turn these into proper tables so they'll be easier to reference. So we'll call this items and we'll call this first cell name. And we'll do the same thing here. We'll call the table terrain and the first cell will be once again name. And because these are numbers, these are not numbers. I'm going to turn them into numbers. So let's go hike minimum length. Let's call it min length. And let's see here. So some of these have numbers, some of them do not. But when they do not, it's minimum length of 0. It's all hikes, right? So here's what I'm going to do. If error text before the space times 1. So if it's a number, it will turn it into a number. If not, it's going to throw up an error. If it's an error, then I want the answer to be 0. There we go. So hike length. Let's go ahead and turn this into a number first. So I'll do the same thing. Text before the space in this cell times 1. And then what we're going to do is we are going to sum ifs. We're going to sum if this was items weight if items min len is less than or equal to that hike length. Enter too few arguments. Okay, because I have to remember that when we do the ifs, the syntax is just a tad bit different. Nope, still doesn't like it. What don't you like? This should be... Okay, so that's what we're doing. That's the criteria range. That's the criteria. And you don't like this. Why don't you like this? Okay, we'll do it over here. Sum ifs. This would be items weight where items min length is less than or equal to that length there. There we go. You like that much better. I guess Excel's just trying to tell me don't do single cell formulas. There we go. Let's go on to level 2. Considering the following planned hikes, how long will they take to carry out? You don't need to consider the weight of your pack. Provide your answer in minutes, rounded to the nearest integer. Your speed varies depending on the terrain. So we have a list of terrains here. We have the distance here. So let's go ahead and turn the distance into a number. That will be text before km multiplied by 1. And for the terrain, that's going to affect the speed, right? Yep. So speed. So we're going to XLOOKUP this terrain here. Terrain name, return terrain speed. There we go. So we're going at 20.5 kilometers at a speed of 7 kilometers an hour. So that should be, how does it say to do this? I always get this mixed up. 20.5 divided by 7. So let's go ahead and 20.5 divided by 7. That gives us the number of hours. Multiply that by 60. That should give us the number of minutes. Round that to 0 decimals. And that will get us the answer for this level. There we go. All right, level 3. This time you need to consider the weight of your pack. First, determine the planned duration of your hike using your base speed, hike distance divided by base speed. Second, calculate the weight of your pack based on the planned duration of the hike. Third, calculate your adjusted speed, which is base speed times 1 minus pack weight in grams divided by 10,000. What is your adjusted speed on the following hikes? Provide your answers in meters per hour. All right, so let's take this step by step. Determine the planned duration of the hike using your base speed. So speed is going to be, look up that in terrain name, return terrain speed. Speed is not just called speed, it's called base speed or something, right? Yep, there we go. And then distance is going to be text before times 1. And then hike distance divided by speed, so that's going to be duration. Distance divided by speed. There we go. Now we need to figure out the weight of the pack. Pack weight, and that's going to be sum ifs. Was that pack or items? Items weight, where items min lane is less than or equal to this duration there. So the pack weight is going to be 2400. Is that what I get from the example? Yes. Okay, then calculate your adjusted speed. Adjusted speed is going to be the base speed here times 1 minus pack weight in grams divided by 10,000. And then adjusted time. Oh no, we just need the adjusted speed in meters per hour. Okay, so it's going to be that times 1,000. Let me just go ahead and put 1,000 there. There we go. That's the adjusted speed in meters per hour. Excellent. Level 4. Consider the terrain map in the following hikes. All the hikes are 21 cells long. How many cells at each of the following hikes belong to the stated terrain? So we need to consider this terrain map, and it's labeled in colors, not according to this table here. So let's go ahead and change this to fit everything within the table. So to do this, I'm going to do this in 2 steps. First, I'm going to highlight that color, but then I also want to get rid of the borders, because when the borders are along the edges, that's going to affect whether that cell is selected. So anything with this light green color is going to be grass. Everything fills in nicely there. Let's go ahead and do the next one for forest. Take the borders out. Let me move this up here so you guys can see it better. Let's replace that with forest. Excellent. All right, and then we'll just do the same thing for the last 3. Take the borders out. We're going to call this water. Yep. Choose from map by cell. Let's get rid of the words. Let me move this up as well. I'm just basically hitting clear and OK for that one. This one is sand. We'll turn this one, getting rid of the borders, into snow. Oh dear, only 1 replacement. That's not a good sign, because that means it didn't replace the ones on the map. Okay, that's really interesting. Let me just try this again. Oh, maybe I didn't do that right. Yep, that was it. I didn't do that right. All right, let's get the last one here. Rock. Clearing out the borders. And there we go. So now the entire map is labeled. Let's just double check here. I'm just going to check if everything on the map does have a label on it. So we have 1,700 cells there. The map has 1,700 cells. Good. Everything has a label. Excellent. Now I'm going to go ahead and flatten it out. Ooh, nice little visual. There we go. Row, column, value, whoops, address, then value. And we're going to call this terrain map. Let's go ter map. There we go. All right. So 2 column map, ter map row, 2 column map, ter map column. And we're going to use these values to get our addresses. And that will get us our values. Excellent. So now what I'm going to do here is we have all of the cells separated by semicolons. So I'm going to go ahead and split that out. So we get every cell on each individual line there. And then what I'm going to do is I'm going to take that and look up the terrain of that cell. So we're going to XLOOKUP those values from the address, return the terrain. There we go. We get rock, snow, etc. We're going to see if those equal the terrain listed for this question. So now we're given a lot of trues and falses. turning those with a double negative will turn those into ones and zeros, and then we can just sum that up together to see how many cells match the terrain for this question. There we go. All right, level 5. Consider the terrain map of the same hikes as in level 4. Each route is 10.5 kilometers long. How long will each of the following routes take to hike? Provide your answer in minutes. Run it to the nearest. Remember to adjust your base speed for your pack weight. All right, so now we're given the same thing. We're given heights. These are 10.5 kilometer long hikes. I'm going to go ahead and throw this on another sheet. Which level am I on? Level 5. So I'm going to bring the information over there. Alright, and let's go ahead and build this out. So cell, actually, this could be text split this on the semicolon, but that's the roads limiter because I want these to go down. So that's how we can do that. From there, I can get the terrain by using this XLOOKUP function here. And then from there, I should be able to get my speed. Terrain name, terrain speed. And then for there, I should be able to get the time per cell. Now, each cell is 0.5 kilometers long, so I should be able to do 0.5 divided by that. So that's how much time I should take to get through each cell. Let me see, what is my total? My total is 3.14 hours. In my example, I've got 3.14 hours. Good. So let me just add total time here, which is going to be the sum of that. And then from that, the next thing I do is figure out my pack weight. And so my pack weight is going to be sum ifs items weight, where items, just say was it minland is less than or equal to this cell right here. Okay, yes, I know the server is busy. Stop giving me this error. I apologize because that's going to screw up my scoreboard as well. So my pack weight is 2,400. Does that match the example? 2.4 kilograms. Yes. All right, so now we can get adjusted speed for each cell. So the adjusted speed is the base speed times 1 minus pack weight in grams divided by 10,000. So that's going to be, oh, that's not, that should be this one. That's the adjusted speed. So now the adjusted time is 0.5 divided by all of those. So now I get a total time of 4.13 hours. Yes, 4.14 hours. Okay, so total time is that right there. So now I should be able to turn that into minutes. We're going to round to 0 decimal places. So round 60 times this number to 0 decimal places. I get 248. That's what the example gives me. Excellent. And that is how we get the answer there. Let's go delete that. That's fine. All right. Level 6. Time to consider topography. If the next cell is located at a higher altitude band, it takes an additional 0.25 hours to travel through the current cell. All right, let me just save this somewhere else. Oh, maybe it's saved. If the next cell is located at a lower altitude band, the adjusted speed of the current cell increases by 50%. There will be no adjustments for the last cell. Remember that the weight of the pack is determined only by the planned hike duration at base speed, regardless of the topography. How long will the following hikes take? Provide your answer in minutes, running to the nearest minute. Okay, then we have a quite long, detailed example of how that's going to be calculated. So let's see, that's 43 rows. I am going to, let's build this off a new sheet. Whoops, not over there. Let's put it over here. That's where I want to call that level 6. Let's go ahead and take all of that information, put it in there. And then what I believe I can do is type properly. What I believe I can do is I should be able to take a lot of this and just adjust for the topography. But I haven't done the topography yet, so let's go ahead and do that now. We'll call this topo map. And let's go ahead and do the find or replace just like we did before. So we're going to find here sea level, get rid of the borders, and this will be sea level. So I'm going to call this 0, 200, 400, 600, 800. So we'll call this 0. There we go. Let's do the next for 200. I forgot to take the borders out. Okay, so they get the double. Let's just, I believe that the only reason we're getting number signs is because of the width. Yep, it's okay. So everything is okay. Everything is okay. Let's go ahead and do 400. Remove the borders. Yep. We'll do 600. Excellent. And then we'll do 800. Good. And then let's go ahead and just do our double check. So count if the cells here represent the cells there. I get a total of 1700. Good. And then I'm going to go ahead and I'm just going to add the information here too, called topo map. All right, so now everything lines up accordingly. And all right, so we have the cell. Did that actually? Okay, everything's lined up well. That we're lined up well. Let's add the topography. We're just going to XLOOKUP that from this column. Return our new latest column. There we go. And now the next thing we need to do is we need to figure out if we are going up or we are going down or we are going to stay the same place. So we go ahead and shift that to the right and let's do out change. And to do that, oh, this is going to be tough. So what I need to figure out is if the next one is higher than the last one. There's no adjustments for the last cell. So let's see. Drop. Oops. Drop. No. Just one drop. This one, so that will then start on the second one, is larger than that. But because the last cell is not going to count, I'm going to throw this in if NA false. Right? And if that is larger, then we are going up. Okay, and let's do the same thing for if it's going down. I should just be able to copy that and then just change this to less than. And then we'll call this down. Otherwise, let's call it stay. All right, so 400, 600, we go up. 600 to 800, we go up. 800, 600, we go down. Excellent. All right, so now we need to figure out what do we do when we go up and down. This stays the same. This one is going, okay, here we go. This is, okay, so we got the total weight of the pack. We already have that. We got the speed adjusted. Okay, now because we calculate the speed and travel time for each cell, taking into account topography. Here we go. For the up movement, you add 0.25 hours for the travel time, and the total travel time through the cell is 0.4201 hours. Okay, so let's do uptime. Yes. So we start with this one, and we just add 0.25 hours. Okay, so if this is up, then we add 0.25 plus that. Otherwise, we're just going to let it read false, so we don't consider those. All right, and let's do down, and I think with down, its speed is adjusted, right? Oh boy. All right, but I think now let's do down time, because we still need to we need to get time. We need to get consistency here. So here we go. As we move down, the adjusted speed is increased by 50%. So if this is down, we take the adjusted speed and we add 50%. That's going to get us our new speed. So right there, 2.625. Yep. And then we need to turn that into time, which we should be able to just take 0.5 divided by that. Oh, Excel did not like that. If error, we'll just turn it to false because it's trying to divide by 0. There we go. Now, if I did that right, let's see, cell C17 is a grass cell. Oh, wait, no. This one. Cell K24, we're going down to 0.1905. Yes, okay. Okay, this is good, Total time, so if this is up, then we're going to take the time here. If this is down, we are going to take the time from here. Otherwise, we're going to take the time from there. So that'll give us the time for every single cell. There we go. We sum these together, we should get how many times in hours? I get 9.57 hours. Yes, 9.5709. That's good, that's good. So, round. 60 times 9.57 hours to 0 decimals, we get 574. Excellent. Let's do our data table. Oh, what happened there? All right, let's take a look at that one. What happened there? Oh, did this one ended with a semicolon, I bet. Yep. Nice little trick there. That one ended with a semicolon. That's going to turn out blank. We don't want it to turn out blank. So let's go ahead and ignore empty true. Does that fix it? Yes, that fixed it. All right, cool. Let's go ahead and paste that in there, and we are good. All right, off to level 7. Consider both the terrain and the topography. You start your hike at the following locations and move the stated distance in the stated directions. All the hikes are straight line in level 7, including the starting cell in your calculations, e.g. a hike of 1.0 kilometers south from cell B3 would go through cells B3 and B4. How long will the following hikes take? Provide your answer in minutes rounded to the nearest minute. Alright, so I believe what we could do for this one is we could do the same thing here. We just need to figure out all the cells we are traversing to. So let's go ahead and copy this. We can use the same model for level 7. Actually, no. Let's start with a blank sheet. Let's start with a blank sheet for level 7. Because I want to copy all those instructions in. There we go. GHI. And then I should be able to copy everything from this model over. And okay, so that works. So what we need to do is we need to use these two to find out how far we are traveling. So let's figure out how many cells we go through first. So we're going to do a sequence, and that sequence is going to be 9.5 times 2 because it's half a kilometer per cell. So let's do sequence text before the kilometers here times 2. So we should get 9.4 times 2. That should be 19. Yes. Okay, good. Now, row column. Now for the first cell, it should be the row column of this. Oh, you know what? Let me get my directions table going here. So let's get all the directions into a table here. So unique of all of these directions. Row, whoops, column. So for south, we're going to increase the row. For west, we're going to decrease the column. North is decrease the row. East is increase the column. There we go. Now, if I XLOOKUP, actually wait, let's do row column here, just so I lay it out so I don't screw it up. I'm going to XLOOKUP that cell here and bring out the row column there. Now, for this part, what I'm going to do is we're going to take this number plus the difference here. So XLOOKUP, XLOOKUP this direction and this table, returning these cells there. But I need to continuously increase it. So I'm going to take that times this sequence number, but that sequence number is going to subtract by 1. So that means the first one will be 0. It means we're starting on that cell A1, A17, AI7. Yeah, I can read. All right, so we see the row is increasing. That means we're going down. The column stays the same. Excellent. So for this one, I'm going to change the address formula, and I'm going to do address, and I have that all as one array. Choose calls this array 1. For the column is choose calls this array 2, and relative reference. Okay, so we see everything filled in nice and well. I have a total time of 3.09 hours. I don't have a check, so let's check up here. So around 60 times this to 0 digits. It looks about right. 186. Yes, it is right. Excellent. Let's go ahead and run it. Oh, I got a few NAs. All right, let's find out why do I got an ace. Let's do 127. This one, oh, well, that's interesting. Why don't you want to go there? Because B37. Okay, so it's not looking up, so that tells me it's B37. Oh, wait, that shouldn't be B37. Oh, that's why. There we go. East is one column, not one row. That would have been bad. Now let's see if these match up. They do not. 127 is still wrong. Why is 127 still wrong? All right, let's take a look. Let's take a look. East is increasing column. That's correct. B13, C13, D13. Is it all the east ones that are wrong? East, east, it is all the east ones. Why are the east ones wrong? Why are the east ones wrong? 13-2, 13-3, 13-4. Yeah. Right. That's good. 24 kilometers, that's 48 spots. Yes. That should be fine. Going B13, C13, D13. 271, 1244. Why is that not? It's weird that only East is screwing up. I know East is 0 rows, 1 column. That should be the adjustment there. Okay. You don't like those answers. Alright, well, let me continue back and maybe I can find my fix for that later. Bonus one, how many snow cells are located at 800 meters plus? We're going to count ifs where this is snow and this is 800 meters or above. Bonus two, ignoring pack weight and altitude changes. How long would it take to hike every cell of bushland at base speed? Provide your answer now. Let's run it to the nearest hour. Okay, so we are going to go back up here and let's find what the speed of each terrain will be. So X look up this in terrain, name, return terrain, speed, and the time is going to be 0.5 divided by 5 divided by those speeds right there. Sum those all together. I get 261.98. Is it round to the nearest hour? Yes. So we're going to round that to 0 decimals. 262. There we go. Whoops. There we go. Bonus 3. What is the combined weight of all packs used in level 3 hikes, excluding the example? I believe, let's see, level 3 pack weight. There we go. All right. Bonus 4. After hiking all routes in level 4, excluding the example, how many rock cells remain unhiked? All right, so we're going to level 4. All hikes are 21 cells long. Let's go ahead and split this out here. So text splits. This based on the semicolon. Actually, let's ignore empty just to be safe. I did that for the example, even though I don't need to do that for the example. And then for bonus 4, let's bring all the information here. So we'll go to call all of these cells. So that's all the cells we hiked through. Let's figure out all the rocks. We're going to filter these cells where this equals rock. We're going to count how many times each cell was traversed. And we're going to count how many cells were never traversed. So I get 244. There we go. And finally, bonus 5. Which hike in level 5 travels through 5 of the 6 types of terrains? Provide your answer as the game number and the first letter of the missing terrain. So we're going to go to level 5. We're going to take a look at all the terrains here. So let's do this. Let's get all the terrains out. So the terrains are listed there. And let's see, count if this of each terrain is greater than 0. Well, that's not going to be easy to see. Is that going to be easier to see? No? What if I do this? Is that going to be easier to see? Yeah, it's going to be easier to see. And I didn't keep it up for all of them. Fine, I'll do it this way. Alright, so actually by row, sum. There we go, get a 5 down there. We're missing the forest, so it's game 100 is missing the forest. We need to enter our answer as the game number and the first letter, so that's 100F. There we go. All right. So now that we got that in, it's not a complete solve. I probably shouldn't have stopped my timer. In fact, let's keep it going. What is wrong here? What is wrong with my east calculations? That's the weird thing. Is it some? I mean, these are going to the east. Those. I mean, I'll lock these, but that's not what it is. I'll lock all of it. Did that change? Now it says 502. I don't remember 502 being there before. I don't know what I just did. I don't know what I just did. I'm going to have to watch the video back and see what the heck did I just say. All I did was lock, but they're not moving, right? I mean, is that what it was? I just unlock. Was this locked? I don't think anything was locked before. Okay, let me undo. Okay. Undo again. Undo again. Redo that. The answers are still the same. These are the correct answers. I don't know. I don't know what I did, but whatever I did, it seems to have worked, or it must have kicked something into gear and made Excel cooperate. But yeah, there you go. That's how you solve this case. I hope you enjoyed watching this video. Why is my answer? Oh, because I didn't copy the answers over. Let's copy the answers over one last time. Ooh, those answers are in an interesting format. There we go. Now it is complete. We can end the video here. Thank you so much for watching. I look forward to seeing you for the next one.
It's the Excel.